Part 2 for today. If you didn't use too much of your translating equations, you could put solving one-step equations on the same page if you have half a page left. You could. But if you like to separate them, start a new page. So up to you with how you number it. You can do the same number for both or a new page. Your choice, however you feel fit. So we're going to do solving one-step equations. This should be review. You've done this. But we're going to talk about how to write it. And I know my mental math students are not going to be happy with me because what we're going to do is we're going to show our steps. Why do we show our steps? Great question. Because as we go into algebra, there will be equations that we'll need to solve that will have no more numbers. So you can't quite just mental math it, but these properties will still be able to apply. We'll look at one of those examples in class and I will show you. And actually that'll be at the very end of our unit. The last lesson is doing that. So I'll show you a little sneak preview of it in class. So here we go. Feel free to pause and copy this down. I guess we don't need that much space between that. Okay. But these are our examples down here. So you put so when we solve one-step equations, our main goal, is not to make you sick by zooming in and out. So sorry. Okay, there we go. That seems better. Good. So our goal in solving one-step equations is to first isolate the variable. What does that mean? It means get it alone. When we isolate the variable, we want the variable alone on one side. That way we know what it equals when we're done. How do we do this? We use the inverse operation. Now, if you don't remember what inverse operations are, let's look at that. Let's look at that just real quick here. So if we look inverse operations, I'm going to draw a little remembering. And we've been looking at these a lot with our radicals unit here. So if we have addition, what is the inverse operation of addition? Subtraction. If we have multiplication, what is the inverse operation of multiplication? Division. And if we have, let's go with b squared. If we have an exponent, our inverse operation is a square root. And if we're feeling crazy, if we have a cube, our inverse operation is a cube root. That's up to be in there. There, the 3 in the pocket. So those are inverse operations. I'm not going to lie, we're going to focus up here in the top 4. The ones we're used to. I'll show you one of these, but we've kind of been looking at those. Okay, here we go. And then keep in mind, I guess it's not really a step 3, it's more of a keep in mind, whatever you do to one side of the equal sign, you do to the other. So whatever we do to one side, we're going to do to the other. Both sides equal. So if we have this example here, we have g minus 53 is equal to 72. Well, here's our equal sign. Here's our variable. Our goal is to get g alone on that side of the equal sign. And if we look, there's this minus 53 or this negative 53 in the way. That's what we're getting rid of. That's what we have to take care of in order to get g by itself. So in order to get rid of this minus 53, we use the inverse operation of subtraction, which is addition. So we're going to add 53. Whatever we do to one side, we do to the other. So if we add 53 over there, we're going to add 53 over here. Ooh, that looks a little weird. Sorry, it's getting a little squibbly. Now, what that does is negative 53 and positive 53 go to 0. Nothing. Anything plus 0 is itself. So in theory, those are gone. The only thing left over here is g. Ooh, isolated. There it is. G equals. And then we do the math. Okay, we're adding 2 plus 3, 5, 7 plus 5, 12. And we know g is equal to 125. Now, we could always substitute it back in and check. So I will be checking with green here. So if we have our 125 minus 53, we can see, does that equal 72? Well, yes, if we subtract those, and you can set it up to the side and borrow if you want, we get 72 is equal to 72, and we checked it. So you could make sure to get 100% on this test by checking your work. So if you're ever worried and you're like, that looks weird, check it. All right, we're going to go move a little bit quicker through the next two, and I'm going to zoom in so it's not as scribbly and weird. So this time our goal is to get m by itself on the same side of the equal sign. Now that 92 is over there, that's fine. But this 48 is with the m. That's what we got to get rid of. Since it is a positive 48, we get rid of it with a negative 48. Now be careful. Are you watching here? Whatever we do to one side of this equal sign, we do to the other side of the equal sign. So we are subtracting 48 from the 92, not the m. If that is something that is weird to you, one of the teachers draws little train tracks to kind of separate it out so you can see, oh, there's that side, there's this side. Train tracks might be helpful for you. So then when we subtract, look at this, 48 minus 48, 0. Nothing. They're gone. We are left with m is equal to, now we have to subtract. Elemental mathers, don't forget to borrow. See? And when we set it up like this, we know 9. Whoa. We're going to borrow from the 9, that becomes an 8. So we have 12 minus 8, which is 4. And 8 minus 4 is 4. And then we can do a little check here. I said I'd do my checks in green, so we plug it back in. So if we have 48 plus 44 is equal to 92, well, let's check. 8 and 4 is 12. Carry the 1. 4 and 4 is 8 plus 1 is 9. 92 equals 92. Those are the same numbers. We know that for sure. M is 44. We know it. Okay, those are easy. Now, the weird ones. Bum, bum, bum. What operation is that? Well, yeah, it looks like a fraction, but it's division. That's x divided by 4. Don't get scared with fractions. We're just using our inverse operation. So the inverse operation of division is multiplication. So we're going to multiply both sides by that denominator of 4. Now, if you would like, I will show you how and why this works in class. And I'll show you a little quick. Technically, that could be 4/1, and then the 4's divide out. So then all we are left with is x. That was kind of a quick one. So if you want me to, we'll go in detail of why that works in class. Now, I show parentheses for my multiplication because as you get higher in math, the parentheses are more helpful because sometimes you'll be distributing that 4 to other things over here. So keep that in mind. Parentheses will help later on, not the x, not the dot. Whatever other operations there are, I can't think of them. Okay, 9 times 4 is done. Most students get scared and they're like, well, 9 divided by 4 doesn't work. No. You can't go across that equal sign. So again, if you want to draw those train tracks, draw them. So you can see, oh, okay, they got to be separate. Now we can always check. Again, I'm checking in green here. So we have, substitute that in, 36 divided by 4. Does that equal 9? Why, yes, 9 is equal to 9. Lovely, checked. Final one before we practice. Ooh, okay, be careful. What operation is between the 7 and the y if they're right next to each other? Multiplication. Okay, so there is multiplication there. So in order to get rid of the multiplication, we use that inverse operation, which is division. Now, helpful. If we write division like a fraction, sometimes our answers will be fractions, and then we leave it as a fraction. That's fine. Although this one's going to work out nicely. Okay, so we're dividing both sides of the equal sign by what number? The number with our variable 7. That way, 7 divided by 7 leaves us with 1y equals 56 divided by 7 is 8. Now we can always check our work. I'm checking in green. So if we have 7 times 8, do we get 56? Yeah, 7 times 8 is 56, and 56 is the same as 56. Check. In class, we're going to bump it up a notch to 2, 3 multi-step equations. But this is our basis. While you're at home, get a little reminder of how we write these things. So if you notice, this is how your work should be shown. Is all of that in red. Don't forget the red parts where we're showing our work. And we'll practice in class. On the next slide is a conic Hannibal. The next slide is a Khan Academy. Practice. There's only one Khan Academy. Do it.